So let us start this finding a square minus 5a plus 6i. We are being given a, which is a square matrix, 3 by 3. Okay. Now,
Yes, sir.
first thing is you have to find what is a square, which is nothing
A
but
square
a into a.
into A.
Okay. So let us find that. Now, after multiplying, we get final answer, which is 5 minus 1, 2, 9 minus 2, 5, and then 0, 1, minus 1, and minus 2. Okay? So this is what we get. So that is a square.
Yes.
Okay. Now we know since here we have got I, so I is nothing but
1
1,
0
0, 0,
0 0
0, 1,
0
0.
1 0 0 0 1.
Okay. Let us substitute everything there. Okay, like we got
Yes.
what is a square, and we have what is a. Okay, and then 6 multiplied with I gives, this is
Sir,
6.
5 A.
Yeah, 5. Yeah, 5. We have to multiply that. Okay,
Yes, sir.
so we'll put everything together now. Okay,
Yes, sir.
yeah. So a square is that is 5 minus 1,
2
2,
9
9
minus 2
minus 2,
5
5,
0
0,
minus 1
minus 1,
2 minus 2.
minus 2. Okay,
Yes, sir.
okay. Now this plus minus 5 into a, which is a 2, 0, 1, 2, 1, 3, and 1 minus 1, 0. Okay. And plus 6 into, sorry, we have already substituted, so let us put that. So that will be 6 times, so 6 times, that is 6,
6
0, 0,
0 0
0,
0
6, 0,
6 0
0, 0,
0 0 6.
6. Okay,
Yes, sir.
let's find that. So after simplifying, we get this, and then finally, uh, let us find the final one.
Yes, sir.
After simplifying, we get the final matrix, which is, yeah, first is 1, then minus 1, then minus 3, okay, and minus 1, minus 1, and minus 10, and then minus 5, 4, and 4. So this is what we find after simplifying it. So let's find this. So a square is a into a, which is nothing but 3 minus 2, 4 minus 2 multiplied into 3 minus 2, 4 minus 2. then we will be able to find what is a square. Here we get a square as 1 minus 2 and 4 and minus 4. 4 and minus 4. Okay, so
Yes, sir.
let us substitute uh, even Ka also. Okay, so Ka will be K times A, which is 3K minus 2K and 4K and minus 2K.
Minus 2K.
Now, and also 2I will be 2 multiplied into 1, 0, 0, 1. So that will be 2, 0, 0.
2002.
Okay. So we got
Yes,
what is 2I, Ka and A square. Right? Now let us
yes, sir.
put this all this in together. Okay. So let us put that A square, which we found as 1
Minus 2.
minus 2,
4
4
minus 4.
minus 4. And Ka will be
3K
3K minus
minus
2K,
2K.
4K minus
4K minus 2K.
2. This is minus 2, 0, 0, 2.
02.
Yeah. So now first let us look at the right hand side and try to simplify it
Yes, sir.
further. Okay.
Yes, sir.
Yep.
3K minus 2.
Yeah.
Minus 2.
3K minus 2. Yeah. And
Minus 2K minus 0.
yeah, which is minus 2K. That's it. Okay.
Yes, sir.
And then 4K
4K minus 0.
minus
4K.
2K
Yes. Minus 2K
minus 2K.
minus 2.
That's it.
Yes,
Okay.
sir.
Now
Yes, sir.
equating the corresponding elements. Okay. So let us equate
Yes,
it.
sir.
So first thing is with respect to 1. So I'll equate this whole thing with respect to this. So 3K minus 2 is equal to 1.
1.
So we get the value of K, which is this goes to the other side. So this is 3 and then 1. So
1.
K value will be 1.
1.
Okay. Okay. So we have been given this. Let us find when A is the choice. Okay. So given that A as this, okay. So A is given like this. So A prime or A transpose would be equal to
0.
0
Minus A.
minus A
Minus B.
minus B,
A.
which is this. Okay. So let us put this, okay, and find the required one. Okay. Which is E is 0 B minus E 0 C minus B C 0 plus this will be 0 minus A minus B and E minus E, and E C 0. So when we add this, what do we get? So you get this as 0, 0, 0, 0, 0, 0, and 0, 0, 0. Now again, if you multiply with half, okay, so that is also
Yes.
0, 0, 0. Okay. Now this is a plus a prime. Okay. Now likewise, let us find what is a minus a prime. So that is a will be 0, a b minus a 0 c minus b minus c 0 minus this is 0 minus a minus b and a 0 minus c and b c 0. Okay, so okay,
Yes.
so this will be first is 0. Okay, now a and minus of minus, that become plus, so that is 2a plus a.
Yes.
Okay, and then afterwards this will be 2b. Okay, and again minus
Okay.
2a, then 0 2c,
Yes.
and then minus 2b minus 2c, and then 0.
0.
Now let us take 2 outside common. So what do we get?
Yes.
So that is 2 times 0. This will be a, this will be b, and minus a, 0, c, and minus b, minus c, and 0. Now we want to find what is half of this. So divide this by 2. So this 2 gets cancelled. So we'll get the final answer as this. Okay. So this is the final answer. Let me talk about invertible matrices. So suppose if A is a square matrix of order n, and if there exists another square matrix which is of B of same order, then AB is equal to BA is equal to I. Okay. For example, if I take A as this matrix and B as this matrix, so A multiplied with B, I get this as 1, 0, 0, 1. Okay,
Yes.
and which is equal to I, and BA would also result to 1, 0, 0, 1,
0.
which is
0.
equal
1.
to I. So
I.
does B is the inverse of A. B is the inverse of A.
A.
Okay, or you can say that B is equal to A inverse.
A.
Okay, so
Yes.
this is about the invertible matrices or inverse. So by using elementary operations, let us find the inverse of the matrix. Okay. So in order to use elementary rows operations, we may have to write as A is equal to IA. We have to write this. Okay.
Yes.
We get this. Okay. Now let us apply the row operations. Okay. On this. Okay. That is R2 minus 2R1. Let us apply this. So that will be 0 minus 5, which is
Yes.
equal to 1 0 0 1. So we have applied this. Okay. Now further we'll apply on this. Okay, so let us apply on this. Right.
Yes.
Now let us apply that. So what do we get? This you keep it as 1, 2, and even when I substitute for this also, we applying this, we get this. And then let us apply further. That is R1 minus 2R2. Let us apply that. So on the left hand side, you get that as 1 0 and 0 1. Applying it. And then on the right hand side, so hence we got the inverse. So that is A inverse would be 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. This is the inverse of A. So what we have done. Okay.